Welcome to the Developers Insight podcast, where we uncover the intricacies of software projects. I'm your host, Ava. Today, we're delving into the fascinating project called Imagination to Real, which aims to bridge the gap between generative AI and physics simulators. Joining me is Arun, a developer on the project. Arun, welcome.
Thank you, Ava. I'm excited to share some insights about this project.
Let's start with a basic overview. What exactly does Imagination to Real aim to achieve?
At its core, the project aims to enable robots to perform complex tasks by training them using visual data generated from AI models. This eliminates the dependency on actual depth sensors.
That sounds impressive. Could you walk us through the major components of the system?
Sure. The system is built around several components. We have the image maker for generating images using generative models, LucidSim for simulating environments, and a collection of workflow scripts to combine these.
Sounds like a robust setup. What makes the image maker noteworthy within this system?
What makes it unique is its 3_mask_ workflow, which allows images to be generated with specific depth maps and semantic masks, enabling nuanced scene creation.
Interesting. Now, I've noticed a file named actor_critic, py, in the model modules. What role does it play in the project?
That file defines the actor-critic architecture, which is fundamental in reinforcement learning tasks within the simulations. This helps in decision-making for complex movements.
Arun, the project uses an Apache license. Can you share why this particular license was chosen?
The Apache license was chosen because it provides a strong legal framework for open-source contributions while maintaining the freedom to innovate and distribute the software with alterations. It aligns well with our project goals.
That's insightful. Now, moving to the project structure, how do the config files like extra_model_paths, template, YAML play into the system?
Great question, Ava. These configs facilitate linking external model paths and help keep our codebase clean by managing dependencies and model versions seamlessly.
Talking about architecture, are there any design patterns that stand out in the project?
Definitely. One noteworthy pattern is the use of a modular structure. It allows different components to be updated independently without affecting the entire system. This enhances scalability and maintainability.
Excellent. Could you tell us a bit about the file, go1_base.py in the task section?
Sure. That file is integral in defining the base simulation environment for Go1 robot tasks, dictating physical properties and setting initial conditions.
Before we wrap up, is there something technically intriguing about the project's implementation you'd like to share?
Well, one of the most intriguing aspects is how we interface with the Zaka task queue. It allows efficient distributed processing of rendering tasks across multiple nodes, greatly enhancing performance.
That's truly fascinating, Arun. Thank you for providing such an in-depth look at Imagination to Real. Any parting words for budding developers?
Just keep experimenting and learning from projects. The open source community is incredibly resourceful, so don't hesitate to contribute.
Wise words. Thanks again for joining us, Arun. And thank you to our listeners for tuning in. Stay curious and keep innovating. Until next time on Developers Insight.